So part C says write a description of how to figure out your subtotal if you get any number of items. And we've kind of done this already. We're basically taking the cost per item and we are multiplying that by the number of items ordered. And then we're adding on the seating fee. And some of these have numbers associated with them already. And so we have 4 times whatever number of items that we order, and we add the seating fee, which was $5 to that. Part D is very similar. It says using Part C, create an equation that models how much your subtotal will be if you order any number of items. Recall that an equation is just a mathematical statement that compares two things with an equal sign. And so a lot of times equations will have variables, and in this one I'm going to use y to represent the subtotal and 4x plus 5. So this is the equation that we have, and again I'll kind of label these. Y is our subtotal, and x represents the number of items ordered. So that completes this first example. Here is our equation. Example 2 says, let's say that you go to a gas station in Oregon. In most parts of Oregon, it is illegal to pump your own gas, so there is a gas attendant that will fill up your car with gas for you. The price for gas is $3 per gallon, and let's say that you decide to leave the attendant a $7 tip. Create a table like the table in example 1 for at least 3 rows. Make sure to label the input and output of your table. So sometimes these are called T tables. So I'm going to kind of make this cross or a T. And our input is going to represent the number of gallons of gas that we get. And then the right-hand side will represent our total cost. And we want to include at least 3 rows. So let's say maybe if I get 1 gallon, then 3 times 1 is 3 plus 7 would be $10. If I get 2 gallons, then 2 times 3 is 6 plus 7 is $13. And if I get 3 gallons, 3 times 3 is 9 plus 7 would be $16. Now this problem is a little bit different than the previous one in that I can get fractions of gallons. So if I ordered or if I got 3.5 gallons, then 3.5 times 3 is $10.50 plus 7, so our total would be $17.50, which is totally reasonable in an example like this. So I've went ahead and I put 4 rows in there, so that should be good. Part B says create a graph that shows how much your total cost would be if you got between 0 and 4 gallons of gas. Make sure you label your axes. So I'm going to label my axes really quickly. So I've gone ahead and I've labeled my axes as well as put values on our tick marks. And so if I ordered 0 gallons of gas, then I would still end up tipping the gas attendant because I would feel bad. So here's that. If I ordered or if I filled up my tank with 1 gallon of gas, then that would be $10. If I got 2 gallons of gas, it'd be 6 plus 7, which is 13. And if I got 4 gallons of gas, 4 times 3 is 12, plus 7 is 19. And if we check back up at our table, we said that if we got 3.5 gallons, then it would be $17.50. So I could put that like right there. And in this example, it totally makes sense for us to be able to connect this line since we can get fractions of gallons of gas. Let's just go ahead and pretend that's a straight line. I struggle with that. Part C says, write a description of how to figure out your total if you get any amount of gas in your car. So similar to the previous problem, we're going to put the cost per gallon, and we're going to multiply that by the number of gallons that you get. And then we want to add on any tip for the attendant. And some of these have number values already, and some are going to be variables. So the cost per gallon we know is 3 times whatever number of gallons that we get, and then we know that the tip is $7. So now, just like previously, we're going to go ahead and create an equation. So we'll have y equals 3x plus 7. And again, don't forget, here in this case, y is the total cost, and x will be the number of gallons of gas. Okay. So these last two examples have been dealing with linear equations, and that's just an equation of the form y equals mx plus b. And we say that this equation is in slope-intercept form. In this equation that I have here, m represents what we call the slope. And a slope is another way of saying the rate at which something changes, or that constant rate of change. And if you create the ordered pair 0, comma b with whatever this number is here, that represents the y-intercept. In word problems, this can be thought of as the starting point. So if I go back up to this example, our y-intercept is this point here, which is 0, comma 7. Okay? And also in this equation, x represents our input or independent variable, and y represents our output or dependent variable.